Hello everybody. So today I will talk about calculus. The topic today is about differential equations. So now I will show you how to answer. We need to divide both sides by y squared. Next, this is about Bernoulli equation. So I will put about v equals to 1 over y. So if we do first the derivative for the both sides, and we have negative 1 over y squared dy over dx, and this one that is about first the derivative of y. We see that we don't have the negative sign in here, so I will put the negative go to the left. This one we change by v. This one we change by negative dv over dx. Next, this one I will put on the left, and we have negative sv. Later that, we divide both sides by negative 1 plus x squared. Next, we have v and first derivative of v, so we can use about integrating factor. So we need to find about mu s equals to e to the power of the integration. So we see that this one next to v, that is for integrating factor. The integration of this one, we have 1 over 2 ln of 1 plus s squared. Next, I will put 1 over 2 go inside ln. And this one we have like this. That means we multiply both sides by this one. So now we need to simplify 1 plus s squared to the power of 1 over 2 with this one in here. And we have like this. Similar for the second one. Next, we put the integration for the both sides. Now, we can apply the formula in here. That is about the product rule of the derivative. So we have first derivative of y equals to first derivative of a multiplied by b plus first derivative of b multiplied by a. So this one, that is about first derivative of a multiplied by b. This one that is about first derivative of b multiplied by a. So the integration of this one, we have y equals to ab. So the integration of that one, we have v multiplied by 1 plus s squared to the power of 1 over 2. Now I will concentrate on this one. So we can use about integration by trigonometric substitution. So I will put about u equals, s equal to tan t, because if I put this one gone here, we have 1 plus tan t squared. Later that we simplify the power 1 over 2, and then we simplify by ds. ds we have secant of t squared dt. First derivative of tan t, we have this one. Now I will put tan t in here and tan t in here. ds we change by this one. This one we have secant of t squared. So this one we have secant of t. Now we need to simplify secant of t on numerator and denominator. And we know that tan t squared, that is about secant of t squared minus 1. And this one multiplied by secant of t squared and number 1. So now I will show you the technique how to find this integration. So this one we can put secant of t and secant of t squared. Later that we can use about integration by parts. So I will put about u equals to secant of t. Later that we do first derivative for the both sides, and we have secant of t tan t dt. dv we have secant of t squared dt. The integration of this one, we have v equals to tan t. So we have u multiplied by v minus we have du multiplied by v. So we have the integration secant of t tan t squared dt. About tan t squared, we can put into secant of t squared minus 1. And now we need to expand this one and this one. We have secant of t to the power of 3. Negative and negative, we have positive, and we have the integration secant of t dt. And we know that this one equals to this one. So I will put this one go to the right. and this one we have number 2. Later that we divide both sides by number 2. Now we have this one. Now we go back in here. The integration of this one, that is about this one. So 1 over 2 minus number 1 in here, we have negative 1 over 2. The integration of this one, we have ln of the absolute value of secant of t plus tan t. And I will put about c. About t, that is about this one. So we have t equal to arctan of s. And now if we have tan t equals to s, we can change by s. For example, this one and this one. About t, we change by arctan of s. Now we go back in here. So the integration of this one, that is about this one. About v, that is about this one. This is the end. Thank you for watching.